Hello, you're watching a video where I'm watching a video. Look, that's Golan and that's me last week. Look, I trimmed my beard. If you didn't watch this video before, Golan, a guest here on the Coding Train, gave a wonderful lecture about interpolation in from an art historical perspective, and then showed 10 different ways of morphing from a circle to a triangle. So now, in this video, I had to close that, and there's a GitHub repository, which I will link to, which has 14 different ways. Why did I say 10? So many different ways of transforming a circle into a square. Now, I haven't looked at the code for any of these. And so what I want to do, and I have done this before, I failed at it miserably. I'm going to do this twice. I'm going to just try two different techniques. In this video, I am going to try to transform from a circle to a triangle. And the constraint that I want to give myself is that I only want to work with begin shape and end shape and a perimeter of points around a circle. And then I want to be able to take that perimeter and make it into a triangle and come back. There's lots of different ways I could do that. The first way that I'm going to do that is just work with the exact same number of points, but define the shape of the triangle and then move the points around. And this is what unlocks a ton of creative potential. Because the points could spring back and forth, they could mix themselves up, they could use some kind of fancy bouncing easing algorithm, they could twirl, but I'm just going to move them from one spot to the other. So I'm going to set up a template from which you could be creative and you can make your own circle morphing example. You could tweet it with a GIF or whatever, any way you like. Okay, so let's get started doing this. All right, first, actually, before I go over there, one thing we could notice here is that the points of an equilateral triangle rest on the circle. And if I just sort of for a second think of this as 0 degrees, this is 120 degrees, this is 240 degrees. So again, I have to think of it, maybe I should start with this is -90. I should be a little more thoughtful about the math. But I think this is going to be useful because as I'm calculating these points, I want to calculate these points as well to create both of those perimeters at the same time. And there's so many different ways you could do this. Don't get me wrong. I'm trying to pick the simplest, not the most elegant, beautiful, or accurate, just the simplest. Maybe it's not the simplest. I'm sure you could think of some simpler ways. But let's come back over to the code. Now, so the first thing that I need to do is I need to have two arrays. I'm going to say let circle path be an array. Let triangle, and I don't know why, but I'm feeling like I want these to be the same number of characters. So circle path and triangle path. I want arrays. I'm going to put vector objects. A P5 vector object is just an X and a Y. So what I could do here in a really sort of simplistic way, just for a second, is I could, and let's change angle mode to degrees, just to save ourselves some pain. So I'm going to say for let angle equals 0, angle is less than 120, angle plus plus. Now, I probably want to have some sort of variable to keep track of how many points. So maybe let's just make a variable, called it spacing right now. This is not great, but let's say we're going to do something every 10 degrees. Just have it be kind of low resolution right now. So I say angle plus equals spacing. So to get the points along a circular path, I can use polar to Cartesian transformation, which means that if I have a certain angle and a radius, I can calculate the xy here as x equals radius times cosine of the angle, y equals radius times sine of the angle. All right? So that's something that I definitely can do. That's how I want to create the vectors for every angle with a certain radius. Now here's the thing. I really would love to derive these formulas for you, but I will point you instead toward a video where I do that. It's a polar to Cartesian coordinate transformation video. Pretty sure I made one. So now if I come back over here, I'm going to say circle, let v, and let me just make this a so that it's not as long-winded. V, let's say v for vector equals, let me actually say let x equal, and I need some sort of radius. So radius, let's just say 100 for right now. X equals radius times cosine of the angle. Let y equal radius times sine of the angle. Let v equal create vector, and I'm being very long-winded here, x, y. And now I'm going to say circle path dot push v. So if I run this code and I look at circle path, I can see I have 12 vectors. And these are all the points. 100, 0, 98.48, 7, blah, 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 etc. You can see all these points here. Now, in theory, the next point, right, with the angle at exactly 120 would be, and this is a little bit silly that I'm going to do this, because I definitely don't need to do it as 3 for loops, but I'm just going to divide it into 3 just for right now, because I think this will help me. And then, and again, absolutely, all of you can think of magical ways. So now this should give me all the points. And honestly, let's comment these out. Because let's just go, well, I'm not going to get to that. Let's go to the draw part. And because let's at least look at how do I draw that perimeter. So now I want to say stroke 0, no fill, begin shape, end shape. Isn't there some fancy new ES6 way I'm supposed to iterate through an array? I equals 0, that's not even for each. I is less than circular path dot length, I plus plus. And now I'm going to say vertex. So let me say let v equals circular path index I. So I want to look at each of those vectors one at a time. What am I doing here? I want to say begin shape and end shape to draw that path. And I want to say v.x, v.y. So let's see, what do I get here? Oh, there it is. That's part of it. Why is it up there? I want to think about everything relative to the center of the canvas. So at the beginning, I'm also going to say translate width divided by 2, height divided by 2. All right, here we go. There, look, that's 120 degrees, part of a circle. Now, could I possibly get the triangle path as well? Let's see if I can. So I know that what I could do with the triangle path right here is I could say let A start equal 0, let A end equal 120, and then triangle path dot push. I guess I could. I'm just sort of working this out in my head, right? So I have X start, Y start, and this is very silly what I'm doing. X end, Y end. I'm just working this out. So I want the start and end of this line that's the side of the triangle. I want to start at 0 degrees and at 120 degrees. And so I need to do the start angle for the starting point and the end angle for the ending point. And then I want to say create vector xs, ys, and x end, y end. So I just want to, this is just me working out the math, right, of how do I get, I just want to get, this is like this point and this is this point. So if I do a path between those, I'll just draw a straight line. So there's so many ways this could be improved, but let's just see if this is right. Okay, well, I have to also draw the triangle path. And yeah, I guess I'll do that as a separate loop. Triangle path and triangle path. There we go. So you can see now, this, it's going all the way. I didn't have that loop go to the next angle, but the triangle side goes all the way that way. Okay, so I've got both. Now here's the thing. How do I want to do this? I want to figure out these points inside of this loop as well. So I think what makes sense is for me to actually say start angle equals 0, end angle equals 120. Start angle, end angle. Then I want to say start v equals create vector, radius times cosine of start angle. I just want to get those points. I'm going to kind of do it in one line. Radius times sine But why is everything so complicated? Start angle. All right. So I want to get that start v and that end v, which will be end A, end A. So I think I created two vectors. And they're really, I could just call them start and end. This could be all, I wish I could. There's so many ways this could be improved, but I'm working it out. Okay, now, what I want to do is, let's just say, just to like sort of see what's going on here, what if I just say triangle path dot push start? So I'm just going to put that start in a bunch of times. We don't need this anymore. This was me just working it out. So if I run this, okay, nothing. But now, what if I use, there's a lerp function. So there's a lerp function, right? If I use the lerp function, if I have a start and I have an end, and I lerp between those two values by 10%, it's going to give me this point right here. And I can do that with a vector. I can use a lerp with the vector function, linear interpolation, to get 10% from one xy to another xy. So what I'm going to do now is say, so this should be the circle vector, and the triangle vector equals start, I think if I say start lerp, is it going to give me a new vector? I don't know. Let's see. Start lerp end, and I need, you know what I think I need to do? I need to say p5.vector. I want to say p5.vector.lerp, and I want to say I'm going in between the start and the end, and how far along am I? I'm a certain percentage, A, divided by end A minus start A. So the amount to lerp is whatever that angle is divided by end angle minus start angle. That's triangle vector, triangle vector. Okay? So this is now how I'm getting, it's kind of crazy. So I'm getting the circular path the traditional way by calculating these points one at a time. And then while I'm doing that, I know this beginning point and this end point. So let me calculate these points along the way. And let's see if this works. So let me try to run this. Oops, hit refresh. Uncaught type error. Sketch.js line 19. Vectors. That's an easy one. It's just bot vector. Okay, I see the circle. So circular path. It has a bunch of vectors in it. That looks like it makes sense. Let's look at the triangle path. It has a bunch of vectors in it. They all look like they're the same point. I forgot to say the amount. Well, I spent all that time calculating the amount. I need to say lerp between the start and the end by a certain amount. Give myself a little more room here. Now let's try this one more time. There we go. Yay! Okay, so it looks like I have the side of the triangle. This is a lot of work. By the way, the nice thing about this is if you just do the path stuff once, you can kind of have it done for all the different ways you want to do your morphing. But that said, here we go. So now there's got to be a clever way I can go all the way to 360, right? And I could probably use modulus to change the start and the end, right? Yeah, and so by the way, there are all these great suggestions in the chat about how to do the morphing in a smarter way. And I'll get to that. But I'm going to do it this way, just as this is going to unlock, unlock all the potential. Wait, I guess I could just like copy paste this, but I can't bring myself to do this. So what I want to do is this. I want this to go all the way to 360. Right? I want this to go all the way to 360. And then I want the if angle mod 120 equals 0. Again, this is only going to work for a multiple, some number that's going to like get to 120, but that's going to be a multiple of that's going to divide into 120 with a remainder of 0. If the angle mod 120 equals 0, then I should be able to say start A equals start A plus 120 and end A equals end A plus 120, right? I know I could do plus equals, right? I should be able to just move those, and then I also need to redo these, right? So by the way, I should really make a function. Let me just make a function. Polar to Cartesian. And it just takes an r and an angle, and it returns create vector. This is going to make our lives so much less awkward. R times cosine of the angle, r times sine of the angle. And I'm sure I could write that. I should write that with arrow notation, but I'm not going to. All right, so I just want to make this function because that way now I can just say, polar to polar, what did I call it? Polar to Cartesian. Radius start A. And end, this is at least end, radius end A. And then here also, I could say polar to Cartesian, radius A, right? So this sort of makes things a lot less weird. So hold on. Let me just put this back to 120 just to see if this still works. What did I do? Polar to Cartesian thing is not defined. I did some crazy typing. Oh, I pasted something in there I didn't mean to. There we go. That's still working. Now what I can do is I can make this 360 and I can just do this again. And reset these variables. What will this do? Yeah, yikes. I got close. So first of all, that's the wrong place. What is going on? All right, this is not correct. I have to debug this. I actually just debugged it, and now I'm in the future kind of go through what I debugged it, but it took me like probably like 45 minutes. No one wants to watch a 45-minute video. Let's figure out what's wrong. So first of all, I'm going to make the spacing 30 so that it's less, there's less points to work with. I also just want to, I think I'm just going to not bother drawing the circle. So no circle, so I can just see the triangle is messed up. And, okay, so what are some of the things that are wrong here? Okay, this is definitely wrong. This doesn't make sense. A divided by end A minus start A. So let me figure out why that's wrong. So if I'm going from 0 to 120, that's going to work because 60 is 50% of the way through. Now when I'm going from 120 to 240, 180 divided by 240 minus 120, no, I'm wrong. So I need to take 180 minus 120 actually. But another way of thinking of that is use the modulus operator. So because really what I want to do is go 0, 120, 0, 120, 0, 120. That's what I want to do. Golan Levin made a whole video tutorial also about the modulus operator that I will link to that you can watch. All right, so this, let's take a look at this. That is not a triangle. No. All right, so one thing we could do here that'll help a little bit is I could, let me just do this again. And let me draw little circles just to sort of see where those points are. And let me say fill 0. Now look, how interesting. These points are kind of in the correct place, but the path is going crazy. All right, hold on a second. Let's look here and let me because if I just go change this to 120, whoa, that's not even right. Oh, hold on a second. Let's comment this out. Oh, that's right. There's something wrong with this modulus thing. Okay, let's think about this. Let's say, what are the angles? They're 0, 30, 60, 90, 120, 150, etc. What is 0 modulus 120? 0. So I don't want to all of a sudden add 120 to start and end right there at the beginning. Oh, that's a problem. So actually what I want to do is anticipate it. I don't want to do it here. 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 Before I get to the next one, I want to because I want to go from here to here. That's the first part. Then I want to move start and end to do the next part. So actually what I want to do, it's much simpler than all the other things I've been trying. I want to say A plus spacing modulus 120. Yep, oh, that looks right. Yeah, that's right. And so now I can do this. Ah! Thank you. Thank you very much. Good night. That's the end of this video. Goodbye. Thank you. Thanks for watching. All right, I can't believe, I don't know, what am I at? Like, how long have you been watching so far? I haven't gotten to the morphing yet, but this is good. We can go back. Oh, we're there. We're getting there. I'm sure Golan Levin did not have this much trouble. I can now put the circle back in. And I don't need to draw these little ellipses, although they're useful to see. And we now have the circle and the triangle. Now it's a little bit off. I could probably think about the angles more thoughtfully, but I'm just gonna, I'm not really feeling it right now. I'm just gonna rotate everything. I think by, what is it, 30 degrees? There we go. So, and now, you notice that those things haven't closed. That's no problem. I can just add this close parameter to end shape. And now I have the triangle and the circle, and I can go back to spacing of 10, and there we go. We now have the circle and the triangle. Thank you. Thank you. Thank you. All right. So now I need to do the morphing. Well, guess what? Remember all that time I spent figuring out how to do lerp? Well, I can use lerp here. What do I want to do? I'm going to have one more array, which is the, I'm going to call this more path for morph. And what I'm going to do is I'm going to just decide, that in the beginning, I'm going to just make it a circle. So more path push that circle point. So I'm just going to make I'm just going to start as a circle. So and actually what I'm going to do now is I don't want to draw either of these. I just want to draw the morph path. Just want to draw the morph path, and I'm going to do that like this, morph path. And now, okay, there's the circle. Now, what are we going to do? I am going to say, and I'm going to use the lerp function, but I'm going to do the lerp for each x and y instead of the p5.vector lerp. I almost wish I had done that before. But for example, what if I say v.x equals lerp. Oh, I need the, okay, so hold on. Let C circle V, I'm going to do some sort of bad variable names, but CV is for circle path, index I. TV is for triangle path, index I. I guess I could make a new vector each time, but I'm going to say v.x equals lerp cv.x tv.x, and let me put 0 in there. I'm going to make a variable amount, and let's have the amount be happening up here. Let amount equal 0. Okay, so I'm going to lerp the x by an amount and the y by an amount. And you know what? This is so silly. I don't actually need a whole separate array. That's all this extra nonsense. It could be useful, but I'm going to do this in a really simple way. I just want to get an x and a y. So I'm going to say let x equal this, let x equal that. So I want to get a new x and a y, which is some amount in between those two, x comma y. So with the amount at 0, what do I have? All right, circle path. Where am I using more path still? Sketch line 20. Get rid of the more path. I don't need that anymore. So ready, my amount is 0. Semicolon. People are yelling at me. Semicolon, semicolon. Oh, and this should be a y. These should be y's. Circle. With the amount at 0, it's circle. With the amount at 1, it's a triangle. With the amount at 0.5, it's kind of halfway in between. Okay, now we're kind of done. We're kind of done. I could do whatever now. What I'm going to do though is let's smoothly oscillate between 0 and 1. So I'm going to make a global variable. Just call it, I'm going to call it theta because I'm not using theta anywhere else. And I'm going to use the sine function. I'm going to say amount, where do I have that amount variable? Amount equals sine of theta, sine of theta, and theta plus equal 0.1. So the sine function gives us a value that oscillates between -1 and 1. -1 and 1. Oh, but I want a number that oscillates between 0 and 1. So what can I do there? I could use the map function, but probably really easily. I could just add 1 and divide by 2. -1 to 1, adding 1 becomes between 0 and 2. Dividing that by 2 becomes 0 and 1. So here we go. Oh, what's happening here? Everything was going so well. Oh, do I have like no loop going or something? I forgot I'm in angle mode degrees and everything. I was thinking in terms of radians. So let's go up by 5. There we go. Woo. Let's make the stroke weight a little bit wider, thicker. I think I did it. I did the circle morphing challenge. So this is the most basic way. The thing is, this is all of the work, I think, because then now I could do all sorts of other ways of moving the points around. I could calculate them. I could start deleting things out of the array, adding things to the array. There's so many possibilities. I hope this is a video that makes some sort of sense that you find useful in some way. I am going to do one more. You're going to see one after this that will be released at some point where I'm going to do this in a really, another way. It's one of Golan's versions, but I'm not sure which one, where I'm going to take one array and start deleting points. So I'm going to try that next. But make your circle morphing, and this will be on GitHub. You can add to the README to link to your own version of this. You can tweet with the hashtag circle morphing. You could try morphing a circle to a square, other shapes, so many possibilities. I can't believe how long this took me and how many problems I had, and I hope you enjoyed watching this video. Thank you. Thank you very much. Thank you, and good night.